Up to this point, we have been learning how to factor. In the last video, we went over factoring methods including greatest common factor, difference of squares, grouping, and then also how to factor trinomials when the case was when a was 1 or when a was greater than 1. This type of method of factoring, which will be involving factoring cubes, is going to be something that's new. In this case, just like we had a difference of squares, the special case of factoring the sum of two cubes, or the factoring the difference of two cubes, follows a pattern. Factoring the sum of two cubes. First of all, we have to make sure that we can learn the acronym SOAP, which stands for same, opposite, and then finally, always positive. If we look at this factoring the sum of two cubes, in this case, a cubed plus b cubed, this means that we need to be able to take the cube root of both the first and second term. The acronym SOAP refers to the signs in the pattern. So if it was a sum, which means it's a plus, that means the sign in the binomial will be the same or a positive. And then in the trinomial will be the opposite sign, in this case, a subtraction. And then the last sign is always positive, another addition. And so the binomial will always be the cube root of the first term plus the cube root of the second. And then for the trinomial, we're going to square, multiply the two together, and then square the last term. This is very similar to the factoring of the difference of two cubes. In this case, notice if it was started with subtraction, using SOAP again, the binomial would have the same sign, so subtraction, and then the trinomial would be the opposite, which would be the addition sign, and the last would be always positive. So let's try using this method. In this case, let's factor 125x cubed minus 8. Notice we can cube root both 125x cubed and 8. And since it's a difference, then that means that we're going to be using the difference of cubes. If we cube root 125x cubed, we find that that's 5x. And if we cube root 8, that gives us 2. And so we're going to set up our binomial, our parentheses, and then also our trinomial with parentheses, and fill up in our signs. Notice in this case, since this is a subtraction problem, it will be the same for the binomial, the opposite for the first sign in the trinomial, and the last sign will be always positive. And then from there, what we're going to do is we need to write in our terms. So for the binomial, it would be the cube root of each term, so in this case 5x minus 2. But then for the trinomial, we're going to square the first, which will give us 25x squared, multiply the two together, giving us 10x, and then square the last term, giving us 4. So our factored form here would be the binomial 5x minus 2 times the trinomial 25x squared plus 10x plus 4. This is the furthest we can go in this case, since we cannot break down that trinomial anymore. In some cases, when we're given a polynomial, we might have to use more than one method. Take, for example, in this case, when we're trying to factor the polynomial 3x cubed minus 30x squared plus 75x. Step 1, whenever factoring, is always to try to factor at the GCF. If we look here, we notice that in all three terms, we can take a 3 and an x out of every term. So that gives us a GCF of 3x. And then that means we can write what would remain in parentheses, giving us a simplified trinomial of x squared minus 10x plus 25. So from this case then, step 2 is always to look at the number of terms of the polynomial that's left over. In this case, the 3x we can't do anything with, but the x squared minus 10x plus 25 contains 3 terms. And so in this case, we're going to rewrite this then as that 3x times x squared minus 10x plus 25. I'm just rewriting it here to give me a little bit more room. But then we can go ahead into our cross method. Notice here our C value is 25, our B value is negative 10, and so we need two numbers that will multiply to 25 but add to negative 10. In this case, that would be negative 5 and negative 5. And so we can go ahead and split that trinomial into the two factors, x minus 5 and x minus 5. Or we can rewrite that in the case as 3x times x minus 5 squared, which is the given answer. Notice in this case, for all three of the factors that were given, they cannot be broken down any further. One thing to also note here, that the number of factors will always match the degree of the polynomial. So in this case, the degree of the original polynomial was x cubed, or degree 3. Notice in this case, we have 3 factors. Now, it's also possible for us to factor algebraic expressions that contain fractional or negative exponents, even though those are not polynomials. We will have to be able to do this when we further look at trig next semester. So like for example, let's say we want to factor and simplify this expression here, x times x minus 1 to the negative 1/2 power plus x minus 1 to the 1/2 power. If we look at both the terms here, there's only 2. If we try to think about the greatest common factor of these two, we will notice that there's an x minus 1 in common with both terms. But in this case, notice we want the one with the smallest exponent between the two terms. In this case, then, if we take the smallest exponent, the GCF of this polynomial is going to be the x minus 1 to the negative 1/2 power, since the negative 1/2 power is the lower exponent. This means to take out the GCF, we need to take out an x minus 1 to the negative 1/2 power out of both terms. And so when we do that, we have that first term is fine because it already has the x minus 1 to the negative 1/2 power. But in the second term, if we were to take out the x minus 1 to the 1/2 power, that would leave us with an x minus 1 to the positive 1 power. Because if we need to take out a negative 1/2 out of a positive 1/2, that's the same thing as, in this case, subtracting 1, because 1/2 minus 1 is that negative 1/2. And so, if we look here then, if we do our grouping method, and we pull out the x minus 1 to the negative 1/2 power, that leaves us with an x from the first term and an x minus 1 from the second term. So leaving the x minus 1 to the negative 1/2 power alone for a sec, we can then go ahead and combine like terms in that second parentheses. Combine the two x's into a 2x minus 1. And finally, the last thing we need to do here is we cannot have a negative exponent, so we're going to leave the 2x minus 1 on top, but then move the x minus 1 to the positive 1/2 power in the denominator, leaving us with the final answer. This is just another case of using the GCF in order for us to actually simplify an expression further. In this case, remember, simplifying means no negative exponents, which in this case our final answer does. Please pause here and return to any example that you need to if you feel like you need more practice.